Hi everyone, welcome to the very first episode on the distributed systems. And the first we are going to talk about in this episode, what is a distributed system? So distributed system, if we summarize that in one sentence, it's basically multiple computers, we are calling them nodes, working together as one system. So for example, let's say that in every system, right, we have what? We have compute part, we have the database, we have a storage, and so on. So in the distributed systems, those are replicated, which means that for each part we have several machines, but together to the end user they appear as a one logical system. So what makes a system distributed? So again, to reiterate, it's a collection of independent computers that appears to a user as one unified system. So from our side, we see that, let's say that we go to a Google or any other website, we see that as a one, from our side, it's a one system to which we are sending a request. But behind the scene, it's a distributed system. It uses collection of the nodes, computers, machines in order to serve the request. So what makes the system distributed is the first one is the concurrency. It's a many components running in parallel. So another one that each node has its own time, so there is no shared clock in the distributed systems. So independent failure, which means that let's say we have for large system we have tens or hundreds of nodes, machines, and the failure of one, it doesn't mean that it affects the system, so systems keep working, and we are just replacing that node. And also network communication, which means that the nodes coordinate via the messages. So why to use the distributed system at all, right? So the first advantage is that the scalability, so it's not the scale up, we are scaling out, but they're not scaling up. So what it means is, in order for us to handle more requests, we are adding machines and to handle more load. So we are just scaling out. So we are, in order to keep growing, we're just adding more machines, more nodes to our system. Another one is the fault tolerance, so which means that there is no single point of failure. Again, if the one node crashes, the other nodes keep running. We are just replacing that node with another node. Another one is the geographic distribution, so latency, right? Because of the latency, data is, let's say that we have a global system, and in order to serve the user faster, so what we do is if our system is distributed, which means that it has in the different parts of the world, so we are serving a user faster because of the closeness to the user. So example of it could be that the CDN, which we are locating closer to the user, and the requests are from the user from that location specifically, they are routed to the CDNs. So we are serving the user from the nearest location. And also another one is the cost efficiency, so no supercomputer is needed, right? So it's easier for us to grow. So we are, let's say, if we are using the cloud services, we are pay as we grow, right? So we can start with, let's say, 2 nodes, then as we grow, we can add more nodes, so we don't have to have a supercomputer in order to serve thousands or millions of requests, right? So now let's go and see what are the important points in the distributed systems. The first one is the communications. The nodes, they are talked using the messages, right? The protocols that we are using HTTP, we are using gRPC, and we are using Kafka. And what are the challenges, right? Challenges are that the latency, packet loss, and the ordering. We are going to talk about each one of them in our subsequent episodes. And also, communication is essential for the coordination. Another one is that the coordination itself. The coordination means that the nodes agree on who does what. And the algorithms that are used, it's leader election algorithm and the consensus algorithm. For example, let's say example of it could be a Zookeeper that we are using with Kafka. right, in order to coordinate the nodes in Kafka. And it ensures that the orderly execution. And last but not least one is the consistency. Consistency ensures that all nodes see the same state. So important point there is COP theorem. So I have a separate video on COP theorem, what exactly it means. But in a nutshell, COP theorem means that in a distributed system, we have consistency and availability and partition tolerance. We cannot have all of three at the same time. We should have either consistency or availability. So, and the trade-off would be that either our system should be eventually consistent or strong consistent, but it depends on the system, depends on what kind of system you are building. Not every system has to be strong. Not every system should have a strong consistency. What are the examples of the distributed systems? Nowadays, if you think about any system, with 90% of certainty, you can say that that system is a distributed system. For example, let's say Hadoop, that for the file storage, right? For the Kafka that we are using for the message streams, Cassandra, Kubernetes, and the Redis cluster, all of these systems are distributed systems. And the simple rule is that if multiple computers collaborate, so which means that if we are using the multiple computers in order to build our software, in order to run our software, so then that system is distributed system. We talked about the distributed systems and the advantages, but what are the challenges in distributed systems? The first challenge is that the network failure. So what it means, right? When we have a distributed systems, it's basically the nodes are talking with each other. We have tens of and hundreds of nodes that need to interact with each other, and messages might be delayed, they might be lost, or they might be out of order, and so on. The next one is that the clock skew. So it means that each machine's clock drift differently, right? So it matters because that in that case the order of the messages are lost. So we have in the episode 3 we are going to talk about the problem with the clock and the ordering in the distributed systems. The next one is that the partial failure, some nodes may die and another may keep working. So we need to be able to, our system should be resilient for those kind of changes. So the next one is that the COP theorem. So we cannot have consistency and availability in the distributed systems. We need to choose between one of them. I have a separate video again on the COP theorem. I will include that in the description. If you are not familiar with that, it's a important part of the distributed systems. First, you should familiarize yourself with the COP theorem. And the next one is that the complexity. It's hard to debug the distributed systems. So we have tools for how to make that process easier, but it's still challenging process. What are the main architectural styles that are used in the distributed systems? So client and servers. So that's one of the main architectures. So it's basically it's centralized, but on the let's say that we are on the backend side, the systems are mainly distributed. So peer-to-peer, it's a decentralized. For example, the example of it could be that the blockchain and also microservices and data flow streams, stream processing such as Apache Flink, Apache Spark, Kafka, and which is used for the real-time analytics. For example, let's take the very widely used example. It's a real world illustration, how the video streaming works, right? Simplified version of it. So we have a user send a request, that request usually end up in the load balancer, and then we have an API service that is fetching the chunks of the video and serving that to user, and we are using the caching layer for it. And for example, we can use Redis or the similar system or Memcache. So in this case, each of these machines, each of these services, it's not just a one service, it's a cluster of the nodes that are serving for example, for load balancing, for the API services, for the database cluster, and so on, right? In this case, that the multiple machines, that we have a multiple machines and that we have replicated data, but to the end user, all this appears as a one system, right? That's what I mean when I say that all these machines, all these clusters, they appear to the end user from the user's perspective. User is just accessing the website and watching the video, right? But on the backend side, we have for each of these machines, we have the cluster of the nodes. So the quick recaps of what we have, right? In the distributed system. Distributed systems, to sum up, it's a mini computer acting as one. And the goal of it, what are the main goals? If we sum up, then it would be scalability, reliability, and the performance. And the challenges that we have seen earlier, it's failure handling, it's a coordination, and it's a consistency. And the examples of the distributed systems is basically most of the systems nowadays, but one of the most widely used examples, let's say it's a Kafka, it's a Kubernetes, Cassandra, and the Apache Spark.